So here we have section 3.4, exercise 12, and h of x is equal to x squared minus 1 over 2x minus 1. And we would like to know the intervals where this is concave up and concave down, so we need to find our second order critical numbers. So we take the first derivative, and it starts getting ugly. We need a quotient rule, so the derivative of the top is 2x times the thing on the bottom, 2x minus 1, minus our thing on the top, times the derivative of the bottom, 2, all over the bottom squared. Well, since I need to take another derivative, I think I want to do a little simplification. So this is 4x squared minus 2x, and then a minus 2x squared, and a plus 2. Got to be careful of our negatives and so forth. And this is all over 2x minus 1 squared. And so this is 2x squared minus 2x plus 2 all over 2x minus 1 squared. I could factor out a 2. I don't know that it really matters at this point. So I think I'll just take the second derivative. Now, actually, the question is, could this factor into 2x minus 1 times something? Well, it might, but yeah, I'd end up with fractions and so forth. So, I think I will, at least I think I'd end up with fractions. I could try, let's see. Why not, just for a moment. Okay, I need to multiply by something x plus that, and now, so this would have to be a 1 in order to get a 2x squared. And then this would have to actually be a minus 2 to get a plus 2 there. And the question is, well, did that work? I'm quite sure it didn't. But who knows? Let's see. Here we get a minus 4x and a minus... nope, doesn't work. So, alright, h double prime of x is equal to... well, derivative of the top, that is 4x minus 2 times 2x minus 1 squared, and then minus, and the derivative of the top, 2x minus 1 times 2, whoops, so I brought the 2 down, and then multiplied by the 2 on the inside, and then times the thing on the top, so 2x squared minus 2x plus 2, and this is all over 2x minus 1 to the 4th because I squared that. Now, before I multiply everything out, I notice I have a 2x minus 1 and a 2x minus 1, so and there are 4 of them down here, so I'm going to factor that out and cancel with one of the things on the bottom. So in the top I'm left with 4x minus 2. I still have a 2x minus 1 there. Here that whole thing disappeared, so I've got a minus 4 times 2x squared minus 2x plus 2, and on the bottom I have a 2x minus 1 cubed now. So it's not quite as bad as it had been, it's just a quadratic. So this is 8x squared, and there's a minus 4x and a minus 4x, so minus 8x, and then a plus 2, minus, oh, this is getting very convenient, minus 8x squared plus 8x, and then minus 8, all over 2x minus 1 cubed. And so finally, those disappear and that disappears, and so I just get a negative 6 over 2x minus 1 cubed. Okay, so now in this case, if we go all the way back to the function definition back here, we see that we can't have 2x minus 1 equals 0, so that can't be 0. Well, when is it 0? Well, it's 0 when x equals 1/2, and so there's a 0 order critical point, but it's also a first order. The derivative won't be defined, the second derivative. And so that's the only place where we have a problem here. Otherwise, this thing's never 0, right? Because we've got a non-zero, the top can't be 0, and that's the only way to make a fraction 0. And so in this case, that was at x equal 1/2 is where the function was undefined. And so in here we know we would go from minus infinity to 1/2, and we would also go from 1/2 to positive infinity. Those are our two intervals, and so now I just need to evaluate. Well, a very easy thing to put in would be 0, so if I look at h double prime of 0, I get minus 6 over minus 1 cubed, which is 6. And so our on our interval here, well, I'll write it, I guess so. So then concave up on minus infinity to 1/2. And similarly, I can check h double prime of 1, and that's minus 6 over 2 minus 1 cubed, which is minus 6. And so that's concave down on 1/2 to infinity. Okay, so there we go. We calculated the second derivative, found all critical numbers. Those were only where it was undefined, and that was at x equal 1/2. Alrighty, so that is number 12, I think that was.